Luke Gill with Fall Line Builders. Welcome to our topless house here. This was a single-story ranch that we were adding a second story to, so we went ahead and blew the roof off. You can see the hardwood floors are in place for right now. These are all going to go, but as we do our layouts and do our masonry opening adjustments, it's actually helpful to have this down. It makes marking out much simpler, it makes cleaning up much simpler, and then these are going to go as part of our changes to our flooring. So you can also see now the outlines of our interior walls. The exterior walls are all staying for the most part. They're masonry and they're in great shape. We're going to have to add some, an interior wall just on the inside of it to achieve our new code required R values and our air sealing. The interior walls, a lot of them are going back in the same exact place, but we are raising the ceiling height in here by about 7.5 inches. So rather than trying to come in and add a cripple wall above, it's going to be faster and easier to just start from scratch and go up with a new frame wall. What that also meant was all the electrical, everything is now 7 inches too short. So all that came out. So yes, it's a full gut, and we're always trying to approach things as how can we be as efficient as possible to make sure that we're not demoing anything unnecessarily, but also not trying to keep something that we're going to have to work around for the next 9 months and just spend a ton of time and energy and money trying to save something that would have been quicker just to get rid of. So the example of where we're starting, we're going to start from the ground up, obviously. So our perimeter footings, our perimeter walls are already done. All of our floor joists are installed. We've got under this temporary sheet of Advantech, I've got the first of our 2 pier footings dug and inspected, ready to be poured. We've got a second pier footing that needs to go in this location. And we actually have to dig and pour this footing underneath the existing strip footing. So if you tried to get in this crawl space and do this by hand, it would take so long that it would, and be so labor intensive that it would just be almost cost prohibitive. So what we're gonna do is actually just pull out all these joists, all this subfloor, get good access, excavate this out, get it inspected, and then we'll pour both of these footings and we'll be done with our footings. And we're essentially done with the foundation portion of that too. So now we get into our first floor framing. We've got some joists here that are water damage from the old bathroom. Those need to get replaced. We've got some joists that are in good shape, but were hatchet cut. Those are going to need to get replaced. And then we have to think about additional loads. So this was a living room, dining room, and now it's going to be a kitchen with a huge island, ton of weight on that granite. So we are going to have to come in and double up, sister all of these joists here in the kitchen to make sure we don't get any added bounce or sag when we add that new weight. We also have our main girder running underneath here, and we are going to be adding additional load with the second floor that's going to be coming down on this interior load-bearing wall. We're going to have to sister these with LVLs, sister the girder with LVLs. And then there's a couple other points where the new staircase is going, again, wasn't here originally, where we have some new cased openings going, some point loads from above that we're going to have to be adding in different LVLs or extra joists. So it just makes sense to pull this up, all that in. So imagine if you had to try to shimmy in an 18-foot, 9¼ LVL into this crawl space, and we've got guys on their hands and knees or on their backs most likely trying to secure this in. It's just going to take hours when it could take minutes. So if we kind of collectively add up all the hours it would take, demoing this section of floor is going to be smarter and easier and quicker. And then we're talking about minutes versus hours when we go to put this back in, or overall, hours versus days that it would take to surgically insert all these things. So we've talked about this in a previous video, but the reason that the walls are still sanding is because these are 8-inch thick true masonry walls. So we've got a brick exterior going around the original part of the house, which is going to remain on the first floor. We're going to do a framed second story addition. But these are really, really stout and they're in great shape, so they're going to stay. What you might see here that is a little strange is I've got these boxes that are already covered in zip, and I'm referring to these as bucks. These are window bucks, so this is the exterior and this is the interior. So many of our window openings in this masonry house are changing, and we've done this several different ways over the years, and this is a new method that we're trying. So we've got all of our windows coming from Marvin, and I've got my rough openings for those. So for this one, it's a 32.5-inch rough opening. The actual frame size is 31.5, and then same thing on the height, 64.25, and it's going to be 63.25 for frame size there. So the reason for this is the exact size, exact rough opening for our window. If we add this pressure treated 2x6 material, and I've got 6 9/16 jams, and I sheet the outside with zip, which is going to be our air barrier, I now have a template for the masons. So instead of telling them to make it a certain dimension and them getting their tape out and trying to make sure that each course of brick is perfectly plumb, I've got a template here that as they build their opening, this thing has to fit. And if it doesn't fit, they know they need to adjust their size. So at the end of the day, when we build our interior 2x4 frame wall, this will get attached flush with it. It'll protrude 2.5 inches into this opening, and then the frame of the window extends beyond that, and then our brick mold beyond that, which will flush out with that brick course. So we'll have to see how this works. This is a first time using this method, but talking to our framer and our mason, it just seems to make the most sense. So it was the framing crew that did the actual structural demolition. And the reason for that is because this could be a pretty dangerous operation. We've got a ton of weight up there. So option A, which was considered, was we've got hardwood floors, they're in good condition. Should we try to keep these floors? Well, to do that, we'd have to keep the roof on while we change all of our openings. And we just decided we're doing this in the summer. There's basically a 50% chance of storms every night here in Virginia, and it didn't make sense. So we can work a lot more quickly, we can work a lot more efficiently, and most importantly, we can work more safely if all this load is gone. So now, when we have to increase the width of this, our masons are pulling off 1 course of block and 3 courses of brick, adjusting the width of this, putting it in, and then setting our concrete lintel and our steel angle iron across the front and bricking it back in. And there's no temp walls needed. There's no wasted labor on trying to support this roof load ahead, which was gonna have to go anyway. So trying to plan ahead and think about, let's not do anything twice. This is an expensive build, and let's try to be good stewards of the budget and think creatively of how can we move as efficiently as possible, which is going to translate into potential cost savings and safety on our job sites, which is really important to us. So we've got our original wood burning fireplace and chimney here, and this had 3 flues originally, potentially only 2 as I look at it now, but we've got the flue for the fireplace, and then this right here was added for our gas-fired water heater. Originally on the back, when this was a boiler room, there was a different vent that was kind of halfway sealed up. But anyway, this was necessary not just for the, we're going to have a fire in the fireplace at Thanksgiving, but every day when the heat's running, that's how this was vented. Well, we don't need that for venting anymore. We would need it if we were going to keep a wood-burning fireplace, but the discussion was that if anything, this is going to be a gas insert. So do we really need to spend the money to extend this chimney now up to meet code above a second-story addition with a higher roof pitch. There's a lot of engineering that was going to go into anchoring this back and extending it, and the decision was made that, and we did a quick sketch of what it would look like without it from the exterior, and so all we're going to do is drop this chimney down below the new floor load, keep the existing structure and box, and then it either becomes purely decorative or we do a gas or an electric insert in there. So just another one of those kind of easy grabs to save a little bit on the budget and reinvest it, somewhere else in the project. This was an old LVL when they did the original kitchen, and you can see that they just kind of cut down this cinder block wall here and cut it down here. And they did look like they parged this and tried to make this fairly solid. But overall, there's really no connection from the LVL down, and we should have at least 8 inches of bearing. And I can't tell, but it really doesn't look like this extends the full 8 inches out. So we don't like seeing this. This is going away as part of the renovation. Now, this was probably doing a fine job of transferring that load down, but now I've got this big brick gable wall, and it's got great compressive strengths, but there's nothing really keeping it from, flexing back in and out. When this was a full corner and it turned the corner, it was locked in. But now it just has the ability to move a little bit more than we want to. So we're gonna end up tying this back in, and we'll talk to our engineer and see if we need possibly a shear wall here that is epoxy and anchored into this wall, just to give it a little bit more lateral bracing. We also can see that when this goes away, I've got this LVL, which is going to stay and is hung off of this right now. So this gets replaced from about where I'm standing over this new post, 18 feet that way, with a new steel beam, and we're going to have to temporarily support this while we get rid of this wall, as well as temporarily support the ridge for the previous family room addition, which is going to remain. So these two things are kind of all we're left with in terms of temp walls, temporary support that we'll need to do while we put this beam in, and that's one post and that's another post. It's pretty simple. But imagine if we had to do that around the entire perimeter of the house while we change the masonry openings. All of a sudden, that is just not worth it. So there's really nothing else going on in this room. We're not going to touch anything in there, so it makes sense to leave the drywall, leave the framing, and do our temp supports. The rest of the house, since we had to get rid of it anyway, let's do it now and work safely. Another thing as we look about kind of communication, so I'd love to be able to be at every job site for 8 hours a day, but it's just not realistic with multiple jobs and other responsibilities. So it is important to be on the same page. So our framers who did the demolition are coming back to do the framing. So we've had multiple meetings with them, kind of going over the full plan, back and forth discussions, then involving the architect and engineer, again, to make sure that we're all moving as efficiently and we're all on the same sheet of music. Also had multiple meetings with our masonry crew, and just something as simple as this. We make this buck, well, it's a different width than a height. And if this thing got installed 90 degrees while I wasn't here, that's just extra work, extra time, extra money, and we don't want to lose that. So coming over here and just taking the time to label this as number 11, and then labeling this as number 11, laying out our center mark for the masons. And in this case, we were able to, this window wasn't hinged on anything. I can shift this over an inch and I can keep this whole left side jamb. So if there's an opportunity to not do unnecessary work, just to move this a ½ inch so we could have it centered of what it was on the plans, it doesn't really matter here. There are other windows that their center location is very important. It's has it centered on the exterior wall. a doorway, in this case, this new mudroom doorway, is lining up on our new hallway. Those dimensions, even if we did have to pull something over an inch or two, those are important because they keep sight lines, they keep center lines, they keep scale, proportion. But if we have an opportunity like in the mudroom, we're doing our built-ins here, and if our built-ins need to be a ½ inch less, you're never going to see that. But this is hours worth of work that we can pick up a savings on. So as you go around the whole place, you'll see everything's labeled. The number of the window buck, which corresponds to the window going in that location, and then we've got it written down on the floor in most places, a center line, and the rough masonry opening, as well as any other pertinent information. And obviously, we're constantly checking and managing, but this just helps us kind of stay ahead of just silly mistakes. Someone just reads the plans wrong, whatnot. This kind of makes it as simple and easy to execute as possible. That's kind of the overall plan here. It looks a little crazy right now, but overall we're thrilled with the progress we've made, and can't wait to start putting this thing back together.